This question was asked in instrumentation, GATE 2008. It is a linked answer question. We are given a circuit with linear elements. We are asked to find out at time t equal to 0 plus, we are asked to find out what is this current I, and we are also asked to find out what is di2 by dt. It is given that the steady state is reached with switch K open. That means the switch was open initially and the steady state is attained. Then at t equal to 0 it is closed. We have to find out what is this current I and what is di2 by dt at time t equal to 0 plus. Now we will see what is the case for t less than 0 or less than or equal to 0, that is before the switch is closed. We will draw the equivalent circuit and then see how we can solve this. T equal to 0 minus or t less than 0, the switch was open and steady state is attained. Since the switch is open, we can remove this resistance from the equivalent circuit. We have the 2 ohm resistance, the 1 farad and the 1 Henry connected across 10 volts. We know that once the steady state is attained, this capacitor will act as open circuit. What will be the current here? This current will be 0 at steady state. What will be the potential here? We have the entire 10 volt appearing across this open circuit because there is no drops, as there is no current flow through 2 ohm or 1 Henry. So we can consider the initial conditions. That means the capacitor voltage initially, we can denote it as say VC1 or VCI. That means the initial capacitor voltage, which is 10 volts. And what is the initial current? We can denote as IL initial, that is 0 amperes. Capacitor voltage and the inductor current cannot change abruptly. So this is the condition of the capacitor and inductor at t equal to 0 minus. Once the switch is closed at t equal to 0, it should remain the same for t equal to 0 plus also, because it cannot change abruptly. Now taking that conditions into mind, we can redraw the equivalent circuit. Now what is the equivalent circuit once the switch is closed? That means for t greater than 0, we will draw the special case when t equal to 0 plus. That means we have the plus 5 volt source. Now the switch is closed. We have the 1 ohm resistance and the 2 ohm here. Now we are drawing the case when t equal to 0 plus. That means we have the capacitor, but what will be the potential across it? It will be 10 volts because it cannot change abruptly at t equal to 0 plus. Okay, that means we have 5 volts here. What about this part of the circuit? What is the current through inductor? It has to be 0 amperes because inductor current cannot change abruptly. We have 10 volts here. Now what is this current? This is 0. Now we are asked to find out at t equal to 0 plus what is the current I. I is the current in here. Now what will be the current? We have 5 volt here. We have 10 volts here and no current is flowing in this direction. So that means we have 3 ohm across a potential difference of 5 volts, or what is the current I? It will be 5 minus the potential here 10, that is the potential difference across those 3 ohm, divided by 3, that is minus 5 by 3 amperes. So we have found out the first part. Now we have to find out at time t equal to 0 plus what is di2 by dt. It is clear that the current I2 is 0, but that doesn't mean its derivative is 0, because it is tending to change once the switch is closed. So we have to find out what is di2 by dt. How we can do that? What is the voltage across inductor? The voltage across inductor is LdI by dt. So in this equation lies our solution. That means what is di by dt? It is voltage across the inductor divided by the inductance. Now how we can find out what is the voltage across this inductor? We have to find out what is the potential in this direction at t equal to 0 plus. Okay. What is the current through 2 ohm? We have found out it as minus 5 by 3 amperes. What is the potential here? 10 volts. What is the potential here? 10 volts. We have to apply KVL here to find out the voltage between these two points. Let's say this point be A and this point be B. Now what is the current through 2 ohm? We have found out as minus 5 by 3 amperes. The drop across 2 ohm will be minus 5 by 3 into 2 plus 10 volts minus 10 volts, the potential across inductor at t equal to 0 plus. Okay. That means the 10 volt and 10 volt will cancel out. We'll be left with minus 10 by 3. Now we have to find out, this is for t equal to 0 plus. Now we have to find out what is di2 by dt. We have found out what is VL. That means minus 10 by 3 divided by what is the inductance? Inductance is 1 Henry. So di2 by dt at t equal to 0 plus is minus 10 by 3. What is the unit? It will be minus 10 by 3 amperes per second. So we have found out the answer for the second part, which is minus 10 by 3 amperes.